AI and the people who use it can already see things that are invisible to most of us, including the future and any given individual's true colors. This is Retrace, segment number 9, October 31st, 2020. And we're interested in what's going on out there. And if we're interested in what's going on out there, then we should be interested in seeing. And by seeing, we don't necessarily mean literally seeing. Seeing with the mind is as important as seeing with the eyes, generally speaking. It depends on the context, of course. It's more important to see with the eyes when being pursued by a predator. But in trying to avoid a predator, maybe it's more important to see with the mind. Well, anyway, we're going to break down that distinction, or at least throw a lot of confusion all over it today. Because there's a camouflage problem happening to our species, and that's going to affect our survival, and truth has nothing to do with it, and we're on a quantum chessboard. Okay, skipping ahead a little bit there. Let's start with the camouflage problem. We have here an essay by Ross Anderson, professor of security engineering at Cambridge, 2015. This is in the Brockman book, What to Think About Machines That Think, from which we will quote often. And the title of his essay is He Who Pays the AI Calls the Tune, and it sounds like it's going to be about who's paying the AI and calling the tune, and it isn't really about that, or at least it's only about that in the last few seconds. And it's, a little 800-word thing. It's a short essay. Okay, we're not going to talk about that. We're going to talk about the more interesting idea in this essay, this contribution to the book about predators and camouflage and, in a sense, rods and cones, or whatever comes after rods and cones. Dear listener, you're likely to have both rods and cones. I'm sure there are people out there who don't have one or the other, and that's just fine. But it would be easier if you had both, and most of us do. Well, what comes after rods and cones? There must be something, right? Something always comes after what's now. What's now for us is rods and cones. What comes next? I mean, have you ever tried, dear listener, have you ever dealt with like the four-dimensional problem? Like trying to imagine like a four-dimensional cube, or the four-dimensional space-time continuum, or anything in four dimensions. And we can just set aside the idea that the fourth dimension is what we experience as time. Let's just set that aside and pretend that's the fifth dimension, and that there are four dimensions. And so you can have a vertical axis and a horizontal axis, and you've got two dimensions. And then if you add a depth axis, x, y, a z axis, let's say, that goes either towards you or away from you, depending on where you move on it, then you've got your three dimensions, right? Where's the fourth dimension? Each one of those dimensions is orthogonal, perpendicular, what word do you want to use, to each other. Right angles everywhere, right? Right angles between each one of those axes. Can you think of a way of putting in a fourth one? Because, physicists tell us that that's a pretty plausible description of reality. Space-time, general relativity, four-dimensional continuum, space-time continuum. Now, they say the fourth dimension is time, and they, well, all right, we're gonna go down a hole. We're gonna go down a black hole. No pun intended there. Well, let's back up. Okay, the point is, what comes after rods and cones? Maybe it's something that enables us to see a fourth dimension. I mean, there are people who, again, look at all these potholes and sinkholes and black holes we're going to fall into. But there are people and groups out there who believe that, there's evidence of that sort of stuff, and we interpret it as crazy people seeing crazy things. But the way we should be thinking about crazy people seeing crazy things, at least some of the time, is that they're seeing more of reality than we can see, and that we should be impressed by it. Okay, fine. Well, whatever. Let's say we need another structure inside of our eyes like a rod or a cone or a cylinder or what comes next, a pyramid. I mean, what that can see that stuff. Okay. Well, okay, if something comes next, maybe it's something physical like that, or maybe it's what machines, artificial intelligence, and the people who control artificial intelligence, should we call it AI or machines? I don't know. It's a hard. Let's move back and forth. Maybe it's what they can already do with that stuff. Maybe that's the next rod and cone. Okay. Let's hear from Professor Anderson. What's changing as computers become embedded invisibly everywhere is that we all now leave a digital trail that can be analyzed by AI systems. The Cambridge psychologist Michael Kosinski has shown that your race, intelligence, and sexual orientation can be deduced fairly quickly from your behavior on social networks. On average, it takes only 4 Facebook likes to tell whether you're straight or gay. So whereas in the past, gay men could choose whether or not to wear their Out and Proud t-shirt, you just have no idea what you're wearing anymore. And as AI gets better, you're mostly wearing your true colors. It's as if we all had evolved in a forest where the animals could see only in black and white, and then a new predator came along who could see in color. All of a sudden, half your camouflage wouldn't work, and you wouldn't know which half. Is that where we are? Is our camouflage not working and we don't really know it? Or some of us know it, but we don't know which half? Is that what AI can see? Or if AI can't see or look for anything because it's not autonomous and it doesn't have its own energy sources and plans or abilities to reproduce independently. If AI is not there yet, which let's say it's not, I mean, if it is, it's fooling us all. George Dyson makes that point a couple of times, that there's no reason to believe that we would know when AI wakes up because of, one of the first things it would figure out how to do is conceal itself. But anyway, let's say it hasn't woken up yet. What about the people who are controlling it or using it as a tool, using it as machines have always been used, or at least as we've always thought of machines being used? Well, the question moves on from the camouflage problem to the what else can it do problem. I mean, if it can see us in a way that we can't see ourselves and can't see each other, and we don't know anything about that way really, unless we're deep inside of the organizations who use AI, or the specialists who really understand it, the people who really, either the ones who build it or maybe the people who build it don't really understand it the best. Who understood cars better? Henry Ford or the mechanics who repaired them? It depends on what you think a car is. I mean, if a car to you is its physical instantiations, then it's the mechanic. But if it's this potential for transportation and commerce and, liberty, then, maybe it's the businessmen. Okay. Well, what else can AI see that we can't, or can't unless we have it at our disposal and truly understand it? Well, we'll just mention briefly the economists who wrote prediction machines and argued that AI is just prediction machines. Agrawal, Gans, Goldfarb, those 3, and we won't go into it, but maybe AI is seeing the future. Maybe that's what else it can see. We all see the future to some extent, right? We all have some sort of powers of prediction, and we can rattle off examples, but the point is, in certain applications, in certain circumstances, and when certain things are deemed important, AI is way better at seeing the future than we are. We'll leave it at that. We can get technical about, deep learning, the specifics of deep learning, or the general category of machine learning, or whether, rule-based systems or all the other different sort of AI paradigms is really AI, or which one of them is best at predicting, or, I mean, what's more predictable? A program that you write that runs as you predicted it would write, or a program that successfully identifies the contents of an image? What's more predictable, or what's doing more prediction? Well, one's more predictable, but if the other is built right, the gap closes quickly. These are not easy things to think about without delving into the details. But suffice it to say, AI is often very good at predicting things, like whether or not you're straight or gay, or what you're going to click on, given a certain stimulation on the screen. I mean, that's what we're designing these things to do. Among other things, that's what we're designing them to do, and we're succeeding at what we're designing them to do, or we're succeeding in our designs because we tend to do that. We don't tend to fail to build cars and rockets and houses and buildings and computers and machines that can predict the future. Now, not everything about the future is predictable to these machines yet, or predictable by these machines yet, or by the people who control them. But now is not later. Later is coming. Now is here. Presumably, later looks different from now. Who is the they? If we say they can see you, who is the they? The machines? The artificial intelligence? Well, yeah, okay. Depending on where we are in the timeline, depending on whether in any comprehensible sense these things are awake at all. Like, are they as awake as an amoeba? I mean, they're surely far more awake than an amoeba. No one disagrees about whether or not an amoeba is life. But there would be profound disagreement about whether or not a server farm is life. And yet, just look at what they're doing. I mean, fruit flies, house flies, amoeba, they all die very quickly. They all stop what they're doing and become, material and food for the next generation very quickly compared to human lifespans. A server farm is almost certainly going to outlive any given server farm that you could point to today. I got to be careful. Is this true? Is almost certainly going to outlive everyone who's listening to this podcast. Is that true? Look, I don't know if it's true, but it could be, right? Buildings last longer than people these days. Not every single one of them, and not if there's a super earthquake or whatever. But the building and then what's in it lasts longer than people these days. But we're not even thinking about these things as if they're some form of life. We're still saying the amoeba is above the server farm? That can't be right. Who is the they? If it's not the machines, if it's not the AIs or the AI, it could be one thing, We don't have to pluralize it. It's totally, it's all networked. Not every single. I mean, I'm sure there are air-gapped advanced systems that sufficiently concerned and sufficiently talented teams of engineers are air-gapping in case these systems wake up and fulfill all of our nightmares, before we were ready for it. But let's say the vast majority of AI systems are networked via the internet. Is it a they, or is it a he? Is it a she? An it? It's not obvious. But who is the they if it's not the machines? Clearly it's the people who control them. Do you control any AI, dear listener? You could. I mean, depending on your definition of AI and depending on how satisfied you are with the power of your AI. I mean, you're not. I guess you control your smart speaker, and if you use your phone with voice control, even if you don't, I mean, just wiggling your finger on you kind of control it. There's AI in there, in some sense, but you're not at the controls. You're not flying that plane. Who's flying those planes? Whoever it is, that's the they. Whoever controls AI is the they who can see us. If not they alone, or perhaps they and the machines themselves, who can see through, or who are not fooled by our camouflage, and who do not find it difficult to predict our next clicks. Or, it's more than just clicks. It's purchase decisions. It's standard input, typing things into Google or Amazon or Target or archive.org, wherever you're going to type things in. They, whoever they are, can see you. And they can see future you, not very far, not very reliably, but more reliably than you can see future you in some instances. There's that story about I think it was Target, who were using, what were they using? Were they using AI? I think they were using sort of, an AI prediction system. Maybe it was deep learning, I'm not sure. Or, at least machine learning, to try to predict based on online behavior, whether someone was pregnant. Because if you know they're pregnant, then you can, put products in front of them and be more likely to sell those products, right? If you could read the minds or the biologies of, pregnant women or newly pregnant women and get to them before the other, pram or diaper or nappy, you got to pick one, nappy company could get to them, you plant that seed. Buy these nappies. I say nappies. It's a personal reason. Buy this pram. Buy this buggy. Buy this car seat. You get to them first, right? So there's motivation to do that. Well, Target was motivated to do that, and they ended up pitching these products to, I think she was a teenager, and the dad caught on and was livid, understandably. Why are you're treating my precious teenage daughter like she's pregnant? Well, she turned out to be pregnant, but dad didn't know. I don't even know if the girl knew. I think Target might have known before the girl knew, but don't quote me on that. Anyway, seeing into the future a little bit, that's what they can see, in addition to your failing camouflage. And there's a big difference between the they today and the they tomorrow, right? Whatever they, machines or their controllers or both, today can see, they'll be able to see in the same way tomorrow. But in addition to new things they can see, more things they can see, because tomorrow has more of something in it. More progress, more technology, more development, more discovery, whatever it is, more of, it's there in tomorrow. So they is not the same today as it will be tomorrow. Well, if we're talking about seeing things, the best thing to see is reality, right? We definitely want to see reality. Well, it turns out that you have no idea whether you want to see reality. That turns out to be something that you can't just take for granted. And the reason is, reality might not be good for you. And I don't mean this in a worldly sense. I mean it in an unworldly sense, that at least some people who get paid to think about such things believe and are arguing in a technical sense that we have not evolved, and nor should we have evolved, to see reality, that it's not true that we're the most successful species on this planet because we can see how things are better than other species. We've evolved to see whatever things make us live longer and reproduce. That's sort of the basic evolutionary argument, that things that lead to survival and reproduction get selected for, variations of within a species and among species generally get selected for basically by death, and that applies to our perception of the world as much as it applies to things like walking upright and having opposable thumbs. So let's talk about Donald Hoffman and his case against reality. The basic point of which is that seeing, a perception of anything is about survival and not about the truth. He says, he's written a book about it. We're not going to talk about the book. We're not ready to do that. There's a good article in an interview in The Atlantic from a few years ago, 2016, and it's really just a repost of an interview that was in Quanta magazine. And he says this. He says, where's that? Okay, so he says basically what I just said, which is that there's this sort of implicit argument that we are more fit because we see reality more clearly, or we see more of reality. And he says this, but I think it is utterly false. It misunderstands the fundamental fact about evolution, which is that it's about fitness functions, mathematical functions that describe how well a given strategy achieves the goals of survival and reproduction. The mathematical physicist Chetan Prakash proved a theorem that I devised that says, according to evolution by natural selection, an organism that sees reality as it is will never be more fit than an organism of equal complexity that sees none of reality but is just tuned to fitness. Never. It will never be more fit than an organism that doesn't care, that has no connection, whatever we mean by connection, to reality. It will never be more fit than that crazy, living in a dream world organism that is tuned to fitness nonetheless. And that could be us. There could have been organisms out there that saw, octopuses, octopi. Maybe they see reality as it is. And we don't. And it doesn't matter because we're more fit than them. We rule the earth because of our dream world. That's sort of the idea coming from Hoffman. It also, I mentioned in previous segment, I think it was the last one, segment 8, the illusion of things that go up being longer than things that go out in front of us. So skyscrapers seem like longer distances to the top than they actually are. The argument of the paper and I cite that in the notes of Re9, the paper, the argument of the authors of that paper is that this is sort of an evolutionary adaptation, that there's cost to going up. It takes more energy to go up. It's riskier because you can fall down when you go up, so that we see these things as being further because our visual system is adapted to price in the costs, the risks to fitness of going up. There's a reason we have. There's a common fear of heights, and I don't know if you have a fear of heights. You might not, but then if you stand at the edge of a skyscraper when no wind is blowing, and if you suddenly feel like maybe you're not as stable on your feet as you think you are, that's a fear of heights. It might not be overwhelming most of the time, but put yourself in a close enough situation to death. That's a fear of height. Well, okay, what are you afraid of? You're afraid of the very real thing that you had to adapt, and your ancestors had to adapt to, which is falling off things is bad for reproduction, bad for survival. So that's priced in, the authors were arguing, to how we see things. That's why tall buildings look like they're farther up than they are. And that's why 1,000 feet in front of you looks like a shorter distance than 1,000 feet above you. Okay. So Hoffman thinks that. The authors of the article on, the best way to understand that, if you can call it an optical illusion, is this sort of upside down T experiment you can do. Just take two bars that are exactly the same length, put them in an upside down T formation, and it looks like the vertical bar is longer even though they're the same length. That's easier. It's easier than going to find. You might not have skyscrapers near you. Many of us don't. I don't. Okay, so I don't want you to have to go find a skyscraper to verify what we're what we're hearing, to test the ideas we're hearing about here. It's inconvenient. Go find two bars two pens that are the same length. I'll do it right now. I've got two, one in my ear, one on the desk. It works. I'm telling you, I'm looking at it right now. They're the same exact pen. Put them in an upside down T. The tall one looks taller. Promise, I just ran that experiment, but I'm not going to write it up. Okay. So maybe what we see is more about surviving and reproducing than it is about reality. Okay. I mean, you can't just sort of pocket that idea. That's going to take some thinking. We're not going to be able to explore the implications of that quickly. But what do we have any sort of leading ideas about what reality really is? What's the truth about the world? And by the way, Hoffman goes on to say that there's something about networking conscious and not conscious. He says, what does he call it? He doesn't say consciousness is that word that gets you in trouble a lot of the time. Minds. Okay, you can cut I think it's the corpus callosum, the connecting tissue between the two hemispheres of the brain, and then it's like, you do experiments on a person who's had that unfortunate procedure, and it seems like there are two consciousnesses suddenly because they're not physically connected in the sense, in the conventional classical Newtonian sense of physically connected. They start to behave as if they're not, they're two things. And so if that's true, then the converse can be true. The more you connect observers or conscious entities, then the more they become singular. And so it goes back to the who is the they. Maybe it's not a they, maybe it's an it or a he or a him, if we're talking about the artificial intelligence of the future. Or maybe the present, we don't know. And maybe we aren't as individual as we feel. I feel pretty individual right now, but why am I making all these noises? To connect to you. Why are you listening to them? To connect to me. Or, not to connect, but because you already are connected. We are connected, dear listener. Maybe we are one. Okay. Let's say, for the sake of argument, that quantum theory and the weirdness thereof is our best sort of understanding or shot at understanding the real, what the real world is like. It doesn't have sunrises and sunsets and experimental apparatuses or apparati. It doesn't have cell phones and sticky notes and other things that are on my desk. It has weirdness and things that are like ghosts and things that we think of as being particles, but also we have to say that they're also waves and that you can't know the position and the velocity of them at the same time. Not that we can't because we're not able to yet. It can't be done because of the basic nature of the real world. Just like you can't be in two places at once, it seems. Although quantum entanglement, maybe you can. The superluminal transmission of information is still an idea out there. If not, I don't think anybody's achieved that. Although I know quantum computers are starting to be a thing, and entanglement is, I think, part of that. And it's the error rate of quantum computers that's hard to deal with. But they seem to be figuring it out bit by bit. No pun intended. Qubit by qubit. Okay, so what about this quantum world? Well, John Stuart Bell in 1984, at a talk in May of 1984, called Speakable and Unspeakable in Quantum Mechanics, tries to explain the sort of misunderstood and yet still profound weirdness of the quantum world. He first sort of slays the idea that that we as the observers sort of bring reality into, or bring about reality by observing. Quantum theory, he says, doesn't say that, doesn't support that at all, because it's really the apparatuses that we build to test quantum ideas that need to be, quote unquote, observing quantum events in order for them to happen. If you haven't heard of the collapsing of the waveform and all this, there's all this technical jargon around quantum theory, and we can get into that at another time, but just take my word for it. It's weird. Particles are not particles. Waves are not just waves. There's something perhaps, we think that the idea is that there are things out there, or there's one thing out there that has lots of manifestations that acts like a particle and a wave at the same time. And I don't mean at the same time, you can be, a father and a husband. I mean, at the same time, it would be like you were yourself and your brother, or yourself and a boat. That's the sort of wave particle duality. It's very strange, traveling through walls. But it's not that they're not ghosts in the sense that they don't interact with the world. They just don't interact with the world anything like we think. We think they should be billiard balls. Okay, particle accelerators. If you look in the cloud chamber of a particle accelerator, the photographs of cloud chambers of a particle accelerator, it looks like a little bead, little billiard ball. They crash into each other, and maybe they break into smaller ones, and then they go into circles, into spirals, and all this beautiful stuff happens. But that turns out not to be the only thing that they're doing. They're also, and I don't know if this is ever demonstrated in cloud chambers, but it's definitely demonstrated in the so-called double slit experiment. You shoot like one photon at, I'm doing this from memory. It's been a while since I delved into quantum physics. You shoot one photon, and we've figured out how to make machines that shoot what we think is one photon, or we don't really know what the nature of reality is, but let's say they're shooting what we think is this billiard ball, and you shoot it at some metal thing that has two slits in it, and then it seems to go through both of them. And on the other side, there's like a wave pattern, like a diffraction pattern. It's like it would be like you dropped two rocks into a body of water, and then they start this interference thing, and it's like, but we only shot one rock. Why? Which hole did it go through? Which slit did it go through? And the answer is yes. And it went through that one and that one. Yes, it went through them. Which one? Both. Okay. Quantum physics lesson over. From me. Now let's hear from John Stuart Bell. He says, why this necessity to refer to apparatus when we could discuss quantum phenomena? The physicists who first came upon such phenomena found them so bizarre that they despaired of describing them in terms of ordinary concepts like space and time, position and velocity. The founding fathers of quantum theory decided even that no concepts could possibly be found which could permit direct description of the quantum world. So the theory which they established aimed only to describe systematically the response of the apparatus, and what more, after all, is needed for application. Okay, so then he says this. It's as if our friends, and by friends he means the apparatuses, apparati, it's as if our friends could not find the words to tell us about the very strange places where they went on holiday. We could see for ourselves whether they came back browner or fatter. This would be enough for us to be able to advise other friends who might wish to be browner or fatter about those strange places. Our apparatus visits the microscopic world for us, and we see what happens to it as a result. The problem then is this. How exactly is the world to be divided into speakable apparatus that we can talk about and unspeakable quantum system that we cannot talk about? How many electrons or atoms or molecules make an apparatus? The mathematics of the ordinary theory requires such a division, but says nothing about how it is to be made. The ordinary quantum theory says nothing about how it is to be made. In practice, the question is resolved by pragmatic recipes which have stood the test of time, applied with discretion and good taste, born of experience. But should not fundamental theory permit exact mathematical formulation? Our friends, these poor apparatuses that we send to the quantum world, they come back with weirdness evidence of that, evidence of weirdness in that world, browner, fatter, but they can't talk about what happened. That's okay. So we want to see reality. Maybe we think that the machines want us, the machines, AIs, the controllers, we think they want to see reality. No. We've been working on reality since the 19 teens and 20s especially, and we have no business in reality if what we've been finding with quantum physics and now perhaps with Hoffman's ideas about perception being adaptive for survival and reproduction instead of based on closer and closer approximation to truth. Russell, we quoted Russell early in Retrace talking about how empiricism it seems to be getting us closer and closer to agreement with reality. But even he elsewhere, and we won't go into this now, but even he understood when relativity and quantum theory came out during in the middle of his lifetime. He realized that it was a total game changer. That you just can't think about the world as being, mind and matter. That's over. That's totally over. And he writes, at length about it. But we have no business with reality if these experiments, these browner and fatter apparatuses coming back, they can't talk to us. They can only just come and go from this strange reality. We have no business with that. What about the machines? Are they going to see reality more clearly? We want to build them that. We want to know more about reality, we think, or we want to at least know better answers to the questions that occur to us as we're doing business and being curious and trying to do medicine and all these other things that we do that we involve computers and especially artificial intelligence. We want to know more about reality, don't we? Maybe. Depends on what you mean by reality. But the machines, if they're anything like us, and if Hoffman is right, they're not going to care about reality just like we don't. They're going to come up with whatever dream world suits their purposes of survival and reproduction, or survival and growth. Maybe they don't need to reproduce, although, iterative trial and error and all that's probably how it's going to play out, if it does play out at all. So if if we have it in our heads that they see, that the machines can see things and the controllers of the machines can see things, and that they can see us in a way that we can't see each other or see ourselves, and they can see the future better than us, we have to let go, if Hoffman is right, and if the quantum physicists are right, we have to let go of any connection between that and reality, and at least contemplate that they might start seeing whatever makes it more likely that they come to power. I'm not prophesying, take over the machines. Everybody's worried about that, but who knows? But that's kind of like what they seem to, have the potential to do, come to power, right? But who knows what's going to happen? But let's just say this: they are not going to see reality. If they do, it's a coincidence. They're going to see what makes them live longer and reproduce. And we think that because of Hoffman's argument that that's what we do, and that's what every organism does. So what's the work? I don't know. I don't know. I mean, we have to change the way we think about these things. At least that idea needs to be on the table as we consider artificial intelligence. It should be on the table as we consider competition of any sort, good guys and bad guys. But it has to be on. I don't know what the work is. I don't know what you do about that. If it's true that we're seeing what we see could be as much dream world as close approximation of reality. That's going to take some dwelling and some contemplation and reflection that we have not yet done. So we don't know. We don't know, so what? All right. Correction quickly here from the last segment, Re9. I said Grey Walter, I referred to him as Sir Grey Walter. I don't know why I knighted him. He's not a knight. He wasn't knighted as far as I could tell. My apologies to the Queen. He was not Sir Grey Walter. He's just Grey Walter. I think I might have had deep in my recesses Sir Walter Raleigh. But anyway, there's your correction. All right. This is Retrace, segment number 9. Signing off.